This is Homework U12 Question 3, and this question is about a particle P of mass 2 kilograms moving in a plane under direction of a single constant force F, and at time t seconds the velocity of P is v meters per second, and we're given these two initial starting conditions. So at t equals 0 we've got this initial velocity minus 5I plus 7j. When t equals 3 the velocity is changed, so we've got a new velocity 1 minus 2j. So immediately this is a question about accelerations. We've got a change of velocity, so we've got acceleration, and it's going to be a question to do with forces because we've now got acceleration and mass, and we're going to use force equals mass times acceleration. So in terms of what the question is asking, find in degrees the angle between the direction of motion of P when t equals 3 and the vector j. So we're going to be looking at this initial condition here. Find the acceleration, which is the change in these velocities, the magnitude of F, which is acceleration times mass. Find in terms of t the velocity of P. So we're going to use acceleration as the change in velocity divided by time, and then find the time at which P is moving parallel to the vector I plus j. So we'll have a look at that one last bit. Okay, so looking at the first part of the question, part A, we've got the initial velocity at t equals 3. We've got the velocity vector is equal to I minus 2j. So basically we're going along I and we're coming down 2j, and the question asked us to find in degrees the angle between the direction of motion and the vector j. So the vector j, you can imagine the vector j is up here, and we're asking for the angle between j and the velocity vector. So basically we're after this angle down here. Okay, so this is basic trigonometry, and so let's go for this angle along here. And if we have got this length 2, this length 1, then we can find theta. So we've got the opposite and we've got the adjacent of this right angle triangle. So we can say that the tan of theta is the opposite, which is 2, divided by the adjacent, which is 1. I'm just using the absolute value here, 2, rather than the minus 2, because I simply want to find that angle and add that to 90 to get this angle along here. Okay, so that tells me now that theta is tan to the minus 1 of 2, and I stick that in the calculator and I get 63.43 degrees. So therefore the angle with J is going to be the 90 plus the 63.43 degrees, which is equal to 153.43 degrees. Okay, now part B, we had to find the acceleration, and we know that acceleration is equal to the change in velocity divided by the change in time. So that's basically going to be the velocity at t equals 3. Let's put the 3 minus the initial velocity, v0, divided by the change in time, which is 3 seconds. So the initial the velocity rather at t equals 3 is the 1 minus 2j. The initial velocity we get from the question, which was the minus 5 plus 7j. So minus 5I plus 7j divided by 3. So I minus 5, that's going to give me 6I, minus 2 minus 7j is going to be minus 9j, and divide by 3 gives me a velocity of 2I minus 3j. Okay, part C of the question asked us to find the magnitude of F, magnitude, not just F, but the magnitude. So we know that force equals mass times acceleration, and the question tells us that the mass is 2, so we've got 2 times acceleration, 2I minus 3J, which is 4I minus 6J newtons. Okay, and so the magnitude of the force is just going to be 4 squared plus 6 squared. So we're looking for the scalar value of this and the square root of all of that, and that gets me 16 plus, that should be a plus in there, we're squaring the minus 6, so that gets me 7.2 newtons. Okay, and the part D asks us to find, in terms of t, the velocity of p. Let's just do part D over here. So we need find in terms of t the velocity of p. So we know the velocity, the final velocity, is equal to the initial velocity plus acceleration times time. So this is obviously the initial velocity, and this is how much the velocity is changing here. So the initial velocity is minus 5I plus 7J from the question. And then the acceleration we've already found in part B, which is 2I minus 3J times time. And we just want this in terms of t. So expand the brackets out here and bring all the i's and the j's together. So we get minus 5 plus 2t times I plus 7 minus 3t times j. Okay, and then the last part of the question said find the time at which p is moving parallel to the vector I plus j. So if it's moving parallel to the vector I plus j, then it must be moving at 45 degrees. So for example, if I've got the vector I plus j up here, it's basically going to be doing that. That would be the vector, say, I plus j. So if we're looking for a vector that's moving parallel to this, then the I component and the j component must be equal. Okay, so again, if we go back to this, we're trying to find the time when the particle is moving parallel to I plus j. So these two parts here, the I and the j component, must both be equal. So when parallel to I plus j, then minus 5 plus 2t is equal to 7 minus 3t, and then simply rearrange, take the minus 3t across to give me 5t, take the 5 across, so the 5 adds to the 7 to get me 12, which finally means that t is equal to 2.412 divided by 5. Okay.